Okay, let's write a Python program to solve this two-body problem. I've modified the program we used in the last worked example, and I've already put in the constants for you. So I've set up the gravitational constant. We're having two objects. I've given one the mass of the Sun and one twice the mass of the Sun. So I'm assuming this is our Sun with a black hole close to it. I've also pre-computed a constant GMM because we're going to be wanting to work that out every time step, so that will save a few multiplications each time step if you do it up front here. Now we've started conditions. I've put the star at position 0, 0, 0 and velocity 0, 0, 0, so it's starting at rest. The black hole I've moved one astronomical unit off to the side. I've just defined the astronomical unit. This is the distance from the Earth to Sun. It's used as a unit in astronomy because all units in astronomy are so big, meters are a bit silly. So it's one astronomical unit off to the side, and I've given it a bit of velocity in the y direction so it won't just fall straight in towards the star or vice versa. We're starting at time 0 and the time step is 0.01 of a day. So I've set up a constant day sec, which is just the number of seconds in a day. We've got one set of lists to record the x and y coordinates of the star and another set of lists to record the x and y coordinates of the black hole. Okay, so now we need to edit the loop. Now what's our loop condition? At the moment it's left over from the golf ball problem. It's z greater than 0, which doesn't make any sense here. Let's have, I don't know, time less than 100 days in seconds. Let's see what happens in the first 100 days of the system. We might need to change that later. Okay, let's compute the force. Now we know our force equations. Force is GMM, that's a constant over mod r cubed times r. You see the minus or plus, depending which object we're talking about, black hole or the star. Okay, so we need to work out mod r and the components of r. So let's work out the components of r. So rx is we defined r as b minus a, so it's going to be the x-coordinate of b minus the x-coordinate of a. We could have defined it the other way around, in which case we'd have different minus signs over here. So rx equals, if I called it xb minus xa, and similarly for y and z. Okay, so now we can calculate mod r, the length of r, the distance between them. But we don't actually need mod r, we need mod r cubed. So we can call it mod r cubed equals, well, mod r is going to be the square root of these squared. So if we take rx squared plus ry squared plus rz squared and raise it all to the power of 1.5, that will give us the answer. So it's the square root of all that cubed. Okay, and now we can work out the forces. So the force in x, we'll call this the force on object B, equals minus, and then we have the gravitational constant we worked out earlier, which I called grav const, times rx over mod r3, and fy equals the same. So I'll copy this, copy and paste, except that'll be the y, and then for z, similarly. Okay, that should do that. Now let's update the quantities. So if this is the force on B, we're going to need to update the positions and velocities of both the black hole and the star. So let's start with the black hole. So I called it XBs and XVBs. So the new XVB is going to be the old one plus the force times delta T over the mass of the black hole, which is mB. Just checking up here, yes, it's a capital M. And then YVB is what I called the Y component. Similarly. And we then look at the positions of the black hole. So the X position will just be XVB times delta T, and similarly for Y and Z. And now we're going to need to do the same thing for the star. So that's all the black hole properties. For the star, it'll be exactly the same, only it'll now be the force in the opposite direction. And it'll all have A's for the relevant variables. Okay. And we've got, to update the list, we've got two lists now because you want to see what's happening both to the star and the black hole. So that and paste. So we can store XA and YA here. Z's are not varying because I've not given it even a velocity or a position in Z, so that won't change. And then we've got a second list for the B parameters with black hole XB and YB. And I've already edited this down here to have two plot commands, once for the XA list, which is going to give a green line where the star's going, and once for the black hole list, which will give a -k, which it turns out is what PyLab thinks this is black. So that should give us a green line for the star and a black line for the black hole. Okay, let's save, and let's see if it works. Oh, it did. Amazing. What you can see is the star started off here at 0, 0, was sucked in towards the black hole. Meanwhile, the black hole was sucked in towards the star. They did a loop around each other and headed out. If you run it for more time, let's see what happens. Let's give it 1,000 days. This will take a bit longer. Save. Run. Okay, so the two of them are drifting through space in this direction, doing loop-the-loops around each other. They seem to reproduce endlessly, so that's telling us our time scale is short enough. What happens if we make the time scale a bit longer? Is it still going to work at 0.1 of a day? Let's have a look. It'll run much faster now. Oh no, that's not looking so good. Let's zoom in a bit, so maybe only after 500 days and see what happens. Still not looking good. 100 days. Okay, so what you're seeing is it's not quite repeating. What's happening is the approximations here, particularly when they were very close to each other, maybe a lot happens in 0.1 of a day, and so then giving it the wrong sort of speed and flinging them out at the wrong velocity. So it looks like for this you need a shorter time step. 0.01's clearly short enough. How about 0.02? That's looking a lot better. Let's run it for a bit longer and make sure. Yeah, that's looking pretty good. Except they're a little bit tilted here. So you see it's coming in and then sloping out a bit, which it shouldn't really be doing. It should be repeating the same pattern over and over again. So even 0.2 is not quite right. So I think 0.01 is probably a safer time step. That looks better.